Okay, so we're still solving for theta in these various equations, and we're going to answer in radians and degrees. So the first thing we want to do is we want to isolate our variable, isolate our trig function. Now, it's located in two locations, so we would like it to be in one. We treat cosecant theta like a variable, even though it's a function, but we're going to treat it like a variable, and there's an understood 1 out front. So if we subtract the 1 cosecant theta, and we subtract 1 cosecant theta, then we get 2 cosecant theta, and we get square root of 8. Okay, so then we would divide by the 2, and we would have cosecant theta, and we would want to simplify. So remember, square root of 8 is the same thing as square root of 4 times square root of 2. So that would be 2 square roots of 2 over 2, which simplifies to the square root of 2. All right, so now to find theta, well, we'll first find alpha. So our reference angle for square root of 2, remember cosecant is the ratio of y. I keep doing that. It's r over y. Okay, so this would be, say that r is square root of 2 and y is 1. Except we know in our unit 2 circle that we've created, r is always is 2. So to turn that in, to make this 2, we need to multiply by the square root of 2. So I do that on the bottom as well, and that tells me that r is 2, and then y is the square root of 2. Now, I know some of you are like, Miss Whitaker, you always told us to, never leave the radical in the denominator, and that's true. We don't want to leave it there, but in order for us to figure out what our reference angle is, we need to know what the value of y is when r is 2, and so it's the square root of 2. So if we look back, square root of 2 for y was at 45 and pi over 4. Okay, so our alpha then is 45 and pi over 4. Okay, now because back here we had square root of 2, it's positive, we know that our reference angle could be 45 and pi over 4 because it could be in the first quadrant because cosecant's positive in the first quadrant. But cosecant is also positive in the second quadrant. Okay, so to find that, we need to come back from 180 or pi. So theta could also be 180 minus 45 or 135 degrees. And theta could also be pi minus pi over 4, which is 3 pi over 4. Okay, so all 4 of those boxes there would work as theta. Okay, so for next one, we want to isolate the cotangent theta, so we'll subtract the 1, and we have square root of 3 cotangent theta equals negative 1. Divide by the square root of 3. Okay, and cotangent theta would be negative 1 over square root of 3. Now, we're not going to leave it here, right? But we do know that the ratio for cotangent is x over y. So we are looking for x to be 1 and y to be the square root of 3. Okay, so let's go back, take a look. Where is x 1 and y is the square root of 3? Well, that happens at 60 degrees or pi over 3. So our reference angle is 60 and pi over 3. Okay, now we know it can't be theta because 60 and pi over 3 are in the first quadrant, and that's where cotangent's positive. This cotangent is negative, and that occurs in the second and fourth quadrants. So to find theta, We will subtract from 180, right, because we're here, going back that way. So, and then we will also subtract from pi. Okay, so we get 120 degrees, and we get 2 pi over 3. Okay, and then we can also come here from 2 pi and 360 going in this direction. So we'd have 2 pi minus pi over 3, which is 5 pi over 3. Or we could say 360 minus 60, which is 300 degrees. Let me go back and put my degree symbols on there to be more accurate. There we go. All right, so those are the 4 possible values for theta in this equation. So, and when secant theta equals negative square root of 2 and cosecant theta equals square root of 2. Right, so secant theta is going to be negative in the second and third quadrants. Cosecant is going to be positive in the first and second quadrant, which means our angle will have to be in the second quadrant. Okay. All right. So now where in the second quadrant? So now we have to look at our for our alphas, right? So I'm just going to start here with cosecant theta, and so let's see. Cosecant theta was r over y. Okay, so r is going to be the square root of 2, except we always said r was going to be 2. So we go ahead and multiply by the square root of 2, numerator and denominator, and we find that we get 2 over the square root of 2. So r is 2 and y is the square root of 2. Well, where does that take place? That's right, at 45 degrees. And pi over 4. Okay, so secant, negative square root of 2, that is our r over x. Okay, so if we treat it similarly, we get that that's going to be 2 over the square root of 2. So where is x square root of 2? Also at 45 and pi over 4. So since it has to be in the second quadrant only, we know we're going to be coming back from the 180 to get there. So we'd be 180 minus 45 degrees, which is 135 degrees. Okay, or pi minus pi over 4, which is 3 pi over 4. Okay. All right, sine of theta is negative 1 and tangent of theta is undefined. All right, so let's kind of think about that for a minute. Tangent of theta is undefined. Tangent theta is the ratio of y over x. We get an undefined if x is 0. Okay, so I'm going to kind of take a quick look at my quadrants. X is 0 at 90. And at 270. Okay. Sine is negative. Okay. Sine, remember, is y over r. So here it would be negative 2 over 2, which would give me negative 1. Up here it would be 2 over 2, which would give me positive 1. So it cannot be that one. Okay, so that means it's got to be this quadrantal. So theta is 270 degrees, or 3 pi over 2. Okay, cosine theta equals 1/2, and tangent of theta must be less than or equal to 0. Okay, so tangent of theta is less than or equal to 0 means tangent's negative. So that happens in the second and fourth quadrants. Cosine is 1/2. That's positive. That only happens in the first and fourth quadrants. So our angle has to be in the fourth quadrant. Okay, so now we look. Cosine is x over r. Okay, so where is x1? Okay, that would be at 60 degrees. So our reference is 60 degrees, or pi over 3. Okay, but we said it has to be in the fourth quadrant. So theta will be 360 minus 60, which is 300 degrees. Or we can say theta is 2 pi minus pi over 3, which is 5 pi over 3 radians. Okay. All right, so cosine theta equals negative square root of 3 over 2, and sine theta must be greater than or equal to 0. All right, so sine is positive. That's what the sine greater than 0 means. Cosine is negative. That happens in these two quadrants, so we have to be up here in the second quadrant. Cosine is still x over r, so we're looking for cosine to be square root of 3. Okay, so cosine, or we're looking for x to be square root of 3. So that happens at 30 degrees. And it also happens at pi over 6. Okay, but we said we have to be in the second quadrant, so our theta will be 180 minus 30 degrees. Or theta will be 2 pi minus pi over 6, which is 5 pi over 6. Okay, all right, let's keep going. Convert to radians, leave in decimal form, and you get to use your calculator. Okay, I'm going to pause just a minute here and get my calculator open. Okay. Alrighty, now I got my calculator open. And I want to turn it on. And I'm going to convert to radians. Okay, so I have negative 235 degrees. To convert to radians, remember, our conversion is 180 and pi. So since I'm going 4 radians, I'll leave pi on top. It says leave in decimal form, so we're saying come on over here, open up your calculator, and simply negative 235 times pi divided by 180. Okay, and we get negative 4.10. Okay, and it's usually we've been leaving it in 3 decimals to 3 decimal places, so we'll say negative 4.102. Negative 4.102. Okay, so 478 degrees. And we'll multiply times pi, divide by 180. Okay, so 478 times pi divided by 180. Okay, and we get 8.343.